Okay, good morning to everyone. And that was The Great Gig in the Sky with Pink Floyd. Good Halloween music. Maybe. Now, we're going to do something a little bit out of order today. Rather than going to what we would typically do as large numbers in scientific notation, I've decided to jump ahead to Unit 5. And here's the title of Unit 5. We go to the document cam. Percents. Now the percent unit is timely in the following sense. We have an election coming up. Proposition K is on the election. What is the essence of Prop K? We're going to do what with the money from taxes? What's the argument? What are they going to do with it? Ernie, this is one for you. Prop K. What are we doing with the money from Prop K? Assuming it passes. Ah, come on now. You haven't been reading all the stuff that's been sent to you at home, right? The junk mail. They're going to take 0.5% and fix the roads. Which sounds good, right? We're going to fix the roads. We got potholes. We have widening that's necessary on 132, known as Blood Alley, because of the accidents there tend to be very messy. So there are a number of things that are supposed to improve with that extra money. Now the argument against it is what? The taxes will last for a long time. This isn't a short-term tax increase. This is a long-term tax increase. And the amount of money is something that you just keep paying. Now if you want lower taxes, you have an argument against it. Let's see what kind of differences 0.5% can make. And remember when we focused on 0.5% before? When did we last focus on 0.5%? What lesson was it? 18. Lesson 18, when we were doing the computational review. We looked at 0.5%. So that's where I'm going to start. How do we change from 0.5% to a decimal? That's the question. So let's go to the board. And let's see what we have. 0.5%. Now, it's been difficult at times for me to find a good illustration of where we spend 0.5%. Where in the past have we done that? What was my illustration? Lesson 18.
Was it car financing?
Nope. House mortgages. And what did the 0.5% get spent for? Mortgage insurance for FHA. So if you had an FHA loan, 0.5% was the amount that increased. So let's just take a, and by the way, the price of houses is down. By how much? What's the percent decrease that we're talking about in the falling price of a house? Ernie will give you one more chance. 1%. More than 1. More than 5.
12.5%.
Well, that's not a bad one at 12.5. Depending on where you are, they're talking about 10 and 20% decreases in housing prices. Okay? So, the bad part is the house you have will also sell for less. Okay? So, it's sort of a bad situation. You get less to pay for a house that also costs less. Now, let's see what happens first with the 0.5%. So what was the median price of a house? Half the houses cost more and half less.
It's like 300 to 700,000.
Depending on where you live, right? So let's say, and I don't know how accurate this is just for Modesto proper, but let's say that the median price is 300,000. That seems a little bit high to me. Maybe as somewhere around 250. But let's say it's 300,000. Now, if you drop 10%, you multiply that by 0.10, correct? And there's a nice way of changing by 10%. Because this is the same as what? 10 over 100, which is the same as 1 over 10. And so if I multiply by 1 over 10, that's the same as dividing this by 10. So this is the same problem as doing this. Divided by 10 to the first. And when you divide by a power of 10, what do you do to the decimal? Dividing by a power of 10, you move the decimal which way? You get a smaller number when you divide by a power of 10, so you move to the left. So the price of that house is dropped by this much, $30,000. So you would be having around $270,000 for the new price. And that's not an unusual figure to find as people sell houses that they've had to drop by maybe 10%. So they advertise it for $300,000 and they end up selling it for $270,000. Now that's a very basic percent problem. Now let's say that you wanted to pay 1/2 more percent on something. This was a discount. This was something that was dropped. You discounted your price. So the buyer saved $30,000. But let's say you take that same house and it's $300,000 and you paid the 0.5% for mortgage insurance. So we want to multiply that by 0.005. That's what your 0.5% is. So your 0.5% is 0.005. Now, another way of doing that problem, and I want you to realize a shortcut here, and for people who work in real estate, work in banking, without calculators, learn to do this very much as something they could do on the fly in their head. They said the following, 1%, so let's look at this problem. 1% is 1 over 100, correct? Now we can do this in a calculator, but it was really this problem. Let's slide over just a little bit now, Leslie, if we could, just to about here. Thank you. So we have times 1 over 100, but that's the same as 300,000 divided by what? 10 to the second, because 100 is 10 to the second. And so what does that do to your decimal point? Moves it over 2 places to the left. So that means it's going right here. So how much are you paying? $3,000 in order to have the mortgage insurance. So if you're buying a $300,000 house and you go into the title company, you're expected to come up with what? $3,000 if you have an FHA loan to pay for the extra amount. Again, it's a percent problem. Now let's change this. Proposition K. You just bought a very expensive car for $300,000. Okay, they do make cars like this. They are very expensive. European, oftentimes, things like Ferraris, Bentleys, Rolls-Royce, and a very expensive Mercedes or something that's very custom made. But note, under Proposition K, this is how much more you would pay in tax. That's just your increase. You would pay $3,000 more if Prop K passes. Now, typical item you buy. Let's say instead of $300,000, you buy $30,000 car. Just $30,000 car. 1 less 0 up here, correct? So you're buying something from Detroit that's in a pricey range, $30,000. What will $30,000 buy you? Not a Mercedes, probably. Probably have to go a little bit higher than that. An Acura. Probably a Lincoln maybe a little bit low for a Lincoln. Acura, somewhere around 30. What else? A pickup that's fully loaded.
Yeah, I was gonna say
A pickup that's really loaded. 4-wheel drive, leather seats, very nicely appointed, 30 grand. Now, if it's one less zero there, it's one less zero here, and so prop K would cost you an additional $300 for the car or the truck. Okay? Now that puts things in a little better perspective. Now if you buy something for $3,000, again we've done what? Dropped another zero, so it's just $30 more for $3,000. And if you buy something for $300, then we can drop another zero and say you're only paying $3 more. So to that extent, when you are buying something for $300, prop K doesn't look like it's hurting you that much. But that's the argument for the additional amount. Now these bring up what we call the percent unit. So let me come back over here to some free space. Percent problems. Now obviously it involves redoing some things that are, as percent problems, reviewing, not redoing, maybe reviewing, things like go from a common fraction to a percent. For example, somebody says, we'll give you a third off. That's a common fraction. What is it as a percent? I like those sales where we say half off, 50%. But typically, 1/3 is used more than others. Common fraction to a percent. From a percent to a decimal. And of course, from a decimal to a percent. And where did we do these problems? That we did this kind of thing. What lesson again? 18. This is going back to what we did in preparation for the midterm. Now there are 3 types of percent problems. So 3 types of percent problems. And the one that we just did is usually written this way. We call the tax a percentage. And the amount of money that we paid for a truck or a car or something like that is called the base. And we typically consider the percent a rate. So we say percentage equals base times rate. And that traditionally has been written with this formula. Percentage equals base times rate, or P equals B times R. Now that often has led to some rather careless language. And somebody says, hey, the percent I had to pay was $30, or the percent I had to pay was $300. No, that was actually the percentage that you paid. The percent was the 1/2%. But this is referred often as the type 1 problem, the first type of problem. And we do it to calculate, okay, so the problems we do, taxes, discounts, are the 2 typical problems we do in our society using base times rate. Okay? And you can see the monitor if I'm in your way. So percentage equals base times rate, and we do it for taxes and discounts. Now just another comment. When we do these kinds of problems and we talk about taxes and discounts, we usually end up with more decimals than we want because we want our answers to the nearest penny. And taxes we typically round up and discounts round down. Now we also get interest in bank accounts. So we get 2 different kinds of interest. You put money in the bank and you're supposed to get, if it's in a savings account, get interest. If you buy something with plastic, you pay interest. Okay, when you pay interest, round up When you get interest, it's rounded down. Okay, so again, if I'm having to get something in my advantage, the business community, banking and such will typically round those numbers down. And if I'm having to pay somebody, they'll round them up. So we don't typically just say round off. So for example, and I probably should use a capital I here for interest, but if you think in terms of the percents for taxes, what are we paying in Stanislaus County right now? What is our tax rate? For taxes you pay on something you buy, like a car, you buy a new stereo. Still 7 3/8 until Prop K either passes or doesn't. So roughly 7 3/8%. Now, different counties, different amount. I understand somebody from Merced this morning said they're at about 7 1/4. I think if you're in San Joaquin Delta County, San Joaquin Delta is the college there. But San Joaquin County would be about, I think, 7 1/4 again. We're a little bit higher here. But if we go with the 0.5%, we're going to be at more than this. 7 7/8%, nearly 8. That's a big difference. Discounts. The discounts you typically get are what? 20%, 10%, 33 1/3, 1/3 off. But 10% discounts oftentimes. Most of us get pretty jaded at this point. 10% we hardly go to the store because it just barely pays the tax. 20%, 1/3 off, starting to talk. Half off? You bet. 75% off. You realize sometimes you have trouble selling things with that much of a discount because they figure something's wrong? Okay, sometimes that's a huge discount. Now, what about interest rates? If you're using plastic, what kind of interest rate are we talking about? Everything from about 5 to what?
25.
As high as 25. So it's hard to find very many credit cards under 5, and they can get as high as 25% if you missed a payment. Okay? So these are the different interest rates we're talking about, and they really impact our life. Paying 25% interest is 1/4 of the amount. So if you owe $100, $25 in interest.
They put that towards interest first. They take
Yes.
interest off first and then your principal.
Yeah, we're going to do a whole unit on simple interest at the end, and it's depressing. I hate to finish the semester being depressed, but that's what we're going to see. By the way, what do you get for interest from the bank in your favor if you put money in the bank? Anybody? Oh, you're dreaming. 6%, I haven't seen that very long time. Interest in the bank.
Probably 1%.
A little better than 1, and some up in the 2 range, and if you have money market accounts, it may go up to 3%, even 4%. We haven't seen sexy 6%, which is the way it was known at some point in a very long time. Housing mortgages. What is the rate of a current house mortgage in this depressed market? 6% typically. Maybe you can get a loan for somewhere under that, depending on how many years you want to pay for it. So, folks, we're in a society driven by what? Percent. Well, that's the first type of problem. Now, what I'm going to do is come back to the document cam for a moment, and I'm going to reference you to a page as you go back to that, Leslie, document cam, and then I'll come back center. Now, the language that I've used so far, base, rate, and percentage, as we come back to me, is very classic. It's been in the literature for decades. The unit, as I present it, I've tried to create a little different idea where I talk about part, of, whole, and percent. But using the classic language, I'm going to ask you to go to page 116. So 116, and here's the formula I just used as we go back to the document cam. Percentage equals base times rate. And I'm going to show you two more formulas, but as we keep looking at what we're seeing there, I'm going to divide both sides of that formula much like we did in our unit on how much. We divided both sides of an equivalence to get a unit fraction. So first, let me write this as a formula. Let's go to the board now. This is the same idea where we let P equal percentage, B equal base, and R equal rate. And I want to get the rate by itself. So I'm going to divide both sides by R, just like we did with our equivalences in how much. And I didn't get that looking at about the same line. That looks a little bit better there. So P over R equals B, R over R. What can I do with my R's? Cancel them. And so this leaves me that base is equal to the percentage. That's a very sick percentage. That's even sicker yet. Let me get an eraser and try to clean that up a little bit. Erasing boards when you're trying to take pictures later is dicey. But it gives me the percentage over the rate. Okay? And I can do what? I can also take this same formula and divide both sides by what? The base. That was supposed to be an R there. And then I get a formula that says R is equal to P over B. Now these are two different types of problems. This is the one right here that I think you probably use most often, in addition to what we just did on the front board. This is the problem you do when you have a test you get back. So if there are 100 points on the test, that's your base. And if you have 90 points on your exam, you convert that to a percent, which when there's 100 questions works out pretty well, or 100 points, and you say that's 90%. And we do that all the time when you get tests back, when we try to get some idea of how well we're doing, because we grade based on percents. This would give you an A minus on the exam. So a rate typically isn't of much interest beyond this. But let's look at one other problem. You go to San Francisco and you buy something for, let's see what I want here, $12. So you're at the wharf, there's some souvenir, and you pay $12 for it, and somebody says that will be 96 cents in tax. And so they want to charge you a total of $12.96. What was the rate of taxes at San Francisco at the wharf, if that's what they charge you? And I don't know what the current figure is, because they have taxes that pay for earthquake retrofitting of bridges and freeways, and they have a variety of things they have to try to pay. And there may be a tourist tax that just because San Francisco is such a neat place to visit. But what would be your tax if this is just what they did? Well, it says you take the percentage, which was 0.96, and put it over what? The base, which was $12. Now, this is probably where it pays to use a calculator. So you take your calculator and see what you get. So I have 0.96 divided by 12.00. Let's see what you get this time. And I'm waiting for... Okay, so you get a 0.08, but then you're supposed to know that that means what? Well, no, that was exact. There was no rounding off. But you know that is what we call 8%, because you move the decimal 2 places to the right. Okay? So if I think in terms of what we were just talking about in the front board, this is where you change from a decimal to a percent. Now that's not an unusual problem to do. When you're hunting for the percent, you pay in different locations. Because just as an example, if you go to Merced, I think you pay less tax than you do in Modesto. You go to Manteca, you pay less tax than you do in Modesto. But you go to San Francisco, you'll pay more tax. Okay. Oh, that's a good one. I hadn't thought of that. Let's take camera 1 for a moment. Let's come back to that right side where I talked about the 3 types of percentage problems. And we have the discounts, we have taxes and interest. And there's one that most of us deal with every time we go out to eat at a restaurant. Whenever you have that ready, make the transfer to there. A tip that you pay. What is the typical tip? 15%, right? So we have tips are at 15% typically. And if you want to be real generous, you go up to what? 20%. Okay, so that's another one we can add there. Now I'm going to consider that problem up on the board right now. Let's go back there just for a moment, Leslie. That's a type 1. Let's call that type 1. And this one's a type 2, as we now go to the side. So the type 2 problem is where you're trying to find the R. So let's pull that in just there, be nice. That's type 2. In this problem, can you give me any other example where you might want to know the interest rate based on information like this? Okay, well, unfortunately with the car loan, you don't really have much of an idea what they're charging you. We need that more in simple interest unit. The last one will do. But other types of problems where you want to know just the interest rate. Anything else comes to your mind? This is one of the few. Well, student loans, again, are in the same problem of what? You don't find the information of R this easily on simple interest problems. By the way, there's a truth in lending law that says they have to tell you the annual percentage rate. What they mean is they have to note or tell you what percent you're paying. Credit cards, again, we can work backwards, but usually it's truth in lending law. Okay, let's slide over a little bit, Leslie, to the left here. And remember, this is now a base problem. I call this the type 3. Now, there aren't very many times you're inclined to hunt for this. I sometimes consider this the nosy neighbor problem. Type 3, where you're hunting for the base. You know what the percentage was, you know how much they paid, and they tell you the interest rate, and they don't tell you the original amount of money. So as we slide over, let's see if we can come up with a problem like that. Somebody wants to brag in a kind of backdoor fashion. Backdoor, type 3 problem. So they tell you, I just paid $30,000 in interest. On a new car. This is the interest. And you know they bought it in Modesto. So you know the interest rate. You know that it's 7 3/8%. That's the rate. And remember, this interest is the same as what? The percentage. This is how much they had to pay. Now they've complained, they only complained in how much they had to pay in interest. But they were really telling you what if you were
That their car was really, really expensive.
a really expensive car and you know how to get the price they paid. What are you going to do? You're hunting for the base, and we know the base is equal to what? Okay, the percentage. Now, you don't have an advantage watching this from home because we don't have a dual camera setup on this sideboard. But is the percentage over the interest rate. So that means I'm going to take my $30,000 and I'm going to divide by what? The interest rate. So that is 0.07375. Okay, let's find out how much they paid. Anybody? You'll need calculators in these. You're going to have a calculator for this unit. I'm going to talk about that in a moment. But what do we get here? 406. Next after that, Teresa? 779. 661. 769 or 779?
406,779.66.
Is there an agreement on that amount?
Yes, so you got that's the same thing she got.
Yep, no.
Was the 406.
Okay, did you divide by 0.07375?
Yeah, that's what you got up there.
And you put that into the 30,000. And you got, now the question is, where does this decimal go?
Let's do this.
It's after the second seven. That's what I got.
So you're saying 40,000.
0.0.
And for 7%, you had to pay $30,000. Doesn't make sense to me.
It's 406,779.661.
So $406,000 for the car.
I'd rather buy a house with that.
Or a house. You paid sales tax on your house. Okay, but the point is, they paid a bunch. And by the way, there are some cars this expensive, and more so. You can pay $1 million for a car. Not want to drive it very far. Think of the repair bill. Okay, broken headlight, $5,000. You get the idea of a Type 3? Not something you're going to do very often. So let's leave that on the board, Leslie. I'll come back front and center again. So I'll give you a chance to make the change there. And I'm going to put something under the document cam if that will help here in a moment. And that's what I want under the document cam. Let's go to the document cam. This is your basic, inexpensive calculator. There we go. That's the full keypad. These sell for about how much, since we're talking about prices of things?
$1.50.
99 cents or less at times. This is not a solar. This is one with a battery. So they sell those sometimes for less. So this is at the 99-cent store. Okay, now, well, where did we go? Okay, this is the 99-cent store. Now this calculator, and you need to realize calculators are all over the place in terms of price. You can pay 99 cents and you can pay $99. You can pay $200. Okay, so it's like cell phones. I saw a cell phone being advertised, or at least talked about, on CNN this morning, and the price was a $1,200 cell phone. Okay, $1,200, and it took great pictures. Okay, and it had great audio, and it had a dial a little bit like an iPod to select numbers and such, but it was advertised for $1,200.
I spent 3 of
And it opened up like a clamshell, and it had a little button to open up, and I mean it had some nice whistles and bells for $1,200.
And you drop it.
Well, you don't drop those.
No, you buy insurance.
Right.
For free.
Okay, you buy insurance. Okay, now, the point in calculators. Let's bring this calculator back up on the screen because I want to put it in some kind of perspective. This calculator, 30 years ago, was $100. Now, it was a version of this. It was done by Texas Instrument, and it was referred to as the data math calculator. It had batteries, and you can probably buy them at a garage sale for 25 cents. Now, that calculator was at a time when the scientific calculator you're talking about that you have sold for just 5 years earlier, $600. Okay? So at about 1967, 1966, HP was making some very nice calculators that you would pay a very high price for. When I went back to do my graduate work for the doctorate, I finally could afford a calculator that had dropped to $250. And it did not do what you can do for $25. In fact, the calculator we're using in STAT right now is $11. And that calculator wasn't even available. You'd have to pay $1,000 for a calculator. By the way, the calculator looked like a desktop. It would take half the space on this desk in front of me, and it was $1,000. And we had to have permission from the department chair to use it when I was doing my master's degree. Oh, the computers took a room like this, just to have the card reader, the CPU, the sorter, the tape drives, and so on would take a room the size that we're lecturing in right now. So things have changed. For $11, what was $1,000? And for $100, what's 99 cents? Now, what I'm going to ask you to do is look at this calculator. I don't feel badly asking you to get a calculator like this for this unit. It's a non-scientific calculator. You can probably search around your house and find one of these. They may have sent one to you free in the mail. Or you maybe can go purchase one for maybe 99 cents. You can't even buy coffee for 99 cents for a cup. Not very many places. Well, what can we do with this calculator that's so special? It has a percent key on it. Okay, you see the percent key at the top. Now we're going to see how we can use this to avoid some of the problems we have. So as we come off there for a moment, I'm going to enter some of the information we've had and show how the calculator can do a nice job of getting answers for us. I'm going to turn on the calculator. Give me a moment, Leslie. As I get on the calculator, I'm going to try to get it to where we have a bright readout. There we go. So you can see the readout. Now I'm going to put my $30,000 into this. Okay, so I'm putting in my $30,000. There's the $30,000 figure. Now I want to divide by. So I'm going to hit the divide by key. And then I'm going to put my 7.375. And it didn't hit hard enough. So I'm going to have to start over. So let me clear that for a moment. Let's see. Where do I want to do that?
The green button.
The green button. So 30,000. Let me hit hard enough with the pen I'm pointing with. There's your 30,000. The divide by key.
You have to hit the green button a couple times.
Just a moment. We'll come off there. I can't do this with the pen. I'm going to have to use my fingers. There's my 30,000 again. Now we'll come off there while I can, okay, for a moment. I'm going to hit it hard enough. There's my divide. And I'm going to put in the 7.375. Now that's all I did was enter that. Okay. Now what I'm going to do is hit the percent key.
Really hard.
Yes, really hard. That's why the cheap calculator sometimes has a disadvantage. But we're going to go ahead. Notice it doesn't even have a name on this calculator. This is the generic calculator. This is like generic medications. We have no name. So we'll call this Curl's Uncalculating Calculator. Now, coming off there for a moment, I'm going to hit the percent key. As I do that, notice what I get. There's my answer. It changed the percent key, changed it to a decimal. And we have right there a decimal point. And so there's your $406,779.66. That does it just moving the decimal automatically. So that's a rather nice thing to do. Now, let's try to tie this together with the other way. You want to get interest. Now, remember, this was dividing. So let's say that you have the 7 3/8%. So let's see what I want to do here. If I start with the amount on the calculator, coming back to the calculator on the document cam, and I want to multiply that by my 7 3/8%, I could get back to my 30,000. But let's make this more interesting. Let's say that they really have this car on sale. It's last year's model. and they're going to give you a 33.33% deduction. So they're going to take 1/3 off. So 33.33%. Now, if they take 1/3 off, your simplest way is divide by 3. But let's multiply by a percent. So I'm going to take this number, and I'm going to hit times, and then I'm going to put my 33.33% and watch what I do in this process. So as we come back to the calculator, here's my amount, and I'm going to hit the times key. So let's come off there for a moment, Leslie. I'm going to hit a times key, and then I'm going to put in 33 point, so let's come back to the calculator. How many 3's do I want after the decimal point?
2.
As many as the calculator will take. Not just 2. So let's come off there for a moment so I can enter in some 3's. Okay, there's what my screen looks like. Now, I don't know if you can see where the decimal, it's after the second 3 from your left. Now I'm going to hit the percent key, and when I do that, what should I get? My discount. So here's what I get off. I save $135,593.21 off the $400,000, well, $406,779.66 car. Now, coming off there for just a moment, Leslie, I'm going to do one more thing. I'm going to take that off and get the new price. So we're going to hit a minus key and then an equal key. So let's see what happens. I'm going to hit a minus key. Let's come back to the calculator. Watch what happens as I hit the minus key and then the equal key. There's your sale price. $271,186.45, a bargain. By the way, you could buy a house in Modesto for that amount of money. That's close to the median price of a house in Modesto at this point, I suspect.
Small house.
Okay? So that's your discount. Now, let's go a step further, because that was the original price. Now, I'm going to add tax to it. So I'm going to take times, and then I'm going to put my 7.375. Here goes. So coming back, I'm going to hit the times key, and then I'm going to hit 7.375 and hit my percent key. When I hit my percent key, wow, that's nice. $20,000 in tax. Now I'm going to hit the plus key and an equal key. And out the door, your $406,779 car, you can drive out the door at 1/3 off plus tax at $291,186.45. Okay. As we come off there, that's the kind of problem we can do with the calculator, and I'm going to ask you to look at page 117. Because this, in essence, is the method that we're talking about. Let me see if I can get the camera to hold for me. Okay. This is the kind of problem we did using the calculator. That's what I want you to practice on for the meeting tomorrow. So get yourself a 4-function calculator like this so that you can enter the numbers in the same way and try to make this problem work on page 117. Now, coming off there for a moment, one of the classic problems with percent and percent problems has been the language. People often use incorrect language. They say, the percent I got was $25. No, that was the percentage. And then they get confused sometimes as to what to divide, what to multiply. And that led me to try something a little bit different. And I'm going to show you the diagram involved, where I've renamed some of those. It's on page 107. And we'll spend time with this tomorrow also. Okay, let's go to that, Leslie. This is on page 107. This is the percent triangle. Now, the whole is your base. That's what I have down here. The percent is your R, and your percentage is the part of. So think of the part of on the top like the point of a mountain. This is your whole, the base, and this is your rate, the percent. Now, when you use this triangle, if you're trying to find, as we are, the interest or discounts, you just cover up this part. And note, you're left with the bottom of the triangle. That means multiply whole times percent. If you're hunting for your test score and you want percent, you cover it up and you have part of divided by whole, and it gives you the correct formula. If you're being the nosy type and you want to know how much somebody paid, you take the part they had to pay divided by the percent you know for the interest or the tax, and it gives you the whole. This will be the way that we will look at percent problems as an alternate. Okay? Now, there are a whole bunch of problems that I need to have you do. There's 3 I want you to focus on for tomorrow. I've already told you that on page 117 I want you to do the calculator problem. And then I want to go back and look at the beginning of this unit. There are 3 problems that review what we've done before. So here's the first one, problem 1. You write each percent as a common fraction. And there are actually 5 parts to this. At the very bottom you find a 1/4 of a percent. That's problem 1. As we come off there, on page 103, I want this done for tomorrow also. This is writing each percent as a decimal fraction. There are actually, again, 5 parts to this problem. D is one we've done today. That's page 103. Then, off there, we're going to go to one more problem. This is problem 3, which is also a review, in which I write each decimal fraction as a percent. There are, again, 5 of these. Page 104. So we have 3 problems, 1, 2, and 3, plus that one problem with the calculator on 117. You're welcome to do other problems in the unit. There is a list of 9 supplementary problems. There are 5 on the unit test problems. But for tomorrow, these first 3 problems, get a calculator and be able to do, again, what we talked about on page 117. Let me review that one more time. And you are going to have this memorized, this method, on page 117. You should memorize that process with your calculator because you won't have this page available to you on the test we do. So this is going to be a very important process. Coming off there for a moment, remember the calculator we're talking about has this kind of keypad on it. I don't want the scientific calculator. Okay, this is the calculator type. Then it can be solar if you want, but I want these keys on it. And then things will work well for us. Now the question, as we come off there, how valuable is this unit? Well, depending on how comfortable you are in calculating percents and discounts, this becomes the base of what we're going to do in the simple interest unit. And if you know what you're doing with a calculator and with interest rates, and you sit down the next time you buy a car, or you buy something else that's a major purchase, and you have choices you can trade off, interest rates for number of years you're going to do, you can save yourself huge amounts of money by knowing what you're trading off. So it becomes a very important problem. And we're going to have a test on this unit on Thursday. So our goal is to finish this unit by Wednesday with the test on Thursday. So that gives us 2 more days. You need to do minimally what I asked for tonight.